Welcome back. Today we are going to start new video of this Google interview series, right? So this time we are going to use problem. We have selected odd even jumps, right? And this is a very good questions and have been asked in the Google interview multiple times. So I will recommend you to please watch the full video and let's go to understand. Okay. So I'll start one quote from ourselves, right? So if you cannot do great things, right, so you can do small things in the great ways. This is said by APJ Abdul Kalam, right? So I ideally want to say that you have to start little questions, right? Small questions, so that you will work on your goal, right? And you will achieve one day with your goal, right? So I will recommend, please watch this series that I have started actually, and I'm going to do multiple questions based on the Google interview questions, right? I will collect all the questions from different portals, right? And I'll put those here. Okay, so if you have any suggestions, please ping me in the comment box, right? And we will discuss there. Thank you guys. Let's continue. So in the statement we have given two two things, right? The first about the odd number and even number jumps, right? So it is saying that statement is saying that we have given you have given an integer array, that is array, and from starting index, right, you can make a series of jumps, okay, from starting index. Okay, and if there is a first, third and fifth jumps in the series, that is called odd number jumps. Okay, if the jumps are first, third and fifth odd number jumps, right, this is called odd number jumps. Okay, and second, fourth and sixth and so on, these jumps in the series are called even number jumps. Okay, means we have given an array, right? An array in an integer array, you can say elements are in integer, where we have given some series of jumps, right? If these jumps are in the odd number, this is called odd number jumps, and if this is given this even number, this is even number jumps, right? Make sure that jumps are numbered, not the indices. These indices are actually, this is not actually indices actually. Okay, these are jumps. Okay, it is saying these jumps are actually numbered, not the indices. Make sure that we will discuss. Okay, and you may jump forward from ith to j index, where I should be less than j, means I should be less than j, in the following way. The first way is during odd number jump, means jumps 1, 2, 1, 3 and 5 and so on, you jump from I to you jump to the index j, right? You are somewhere, let's suppose I, and you are jumping to the ith index. Okay, it means the array at I should be less than equal to array at j, right? Where array at j is the smallest possible value in the array, right? Where the range is there, right? If there are multiple such indices, right, if there is multiple such indices, you can jump only one time with the smallest, right, we have in the possible values, right? And such indices is j. Again it is saying during even number jumps 2, 4 and 6, you jump to the j, and such a of I is greater than equal to this, means this element a of j is largest possible values, right? And if there are multiple such indices j, you can only jump to the smallest, right? So you have to take care of these nodes. It is also saying it may be a case that for some indices, right, there no legal jumps are there. Okay, so this is the things, we have the rules like this one, and we have to follow this one. But a concept is saying that a starting index is a good if starting from that index you can reach the end of the array, means array dot length minus 1 index, right? If you reach there by jumping some number of times, right, possibly 0 or more than once, right, it means this is your good index, and that number of good index we have to return. That we will see here. Okay, So this example we have 10, 13, 12, 14 and 15, right? Let's suppose we are talking about this one. Okay, so this is the array we have given here. I'll start the index 0, 1, 2, 3 and 4. Okay, so here the if I want to jump from these to this or any of these, right? Okay, so I have a possibility range, right? Possible range what we have is I can move to any of the directions, right? From here to here. These are my range, right? Indices from 1 to 4th, right? We can jump. Okay, either one jump or multiple jumps I can do. Okay, so what is the criteria we have? We have to check the elements this range, right? If it is and another is a smallest possible values. So this is 1, 1, 3 and 5, like so this is the indices, right? This is 1, right? So what I will do, I'll check the element which is smallest, right? So in this range 12 is the smallest element. Okay, so I will select not to go here, but I will jump to here. Okay, and I am at this position. So from here, this is the indices 2, right? Now we have to check the next jump, right? So this is the second jump, right? So this is the indices 2, right? And if you'll talk about the indices, right? This is 1, 2 and 3, right? So if we'll take any other jump, right, where we will reach, right? But we have made already one jump. Now one element is left here, 13. So what I will do, I'll check the next element, right? So there is a possibility here and here, right, where we should jump. Okay, so this possibility can we come to either here or we can go to here, right? Okay, so if let's suppose we are going to this one, so we reach here. Okay, and if we want to jump from now here to here, right, or here to any other place, right? Let's suppose, so we are reaching at the end here. Okay, so either we'll come to here and here. So only one possibility is coming here, like we are reaching at the end, right, from here to here, or from 12 to reach to any other position, right? So maximum two way we are getting here. Okay, we'll discuss here. Let's suppose, so what we are talking about here, we have given 10, 13, 12, 14 and 15, right? This indices given. So if indices are 0, 1, 2, 3 and 4, right? So if we'll start with the starting index is 0, we can make the first jump to 2 here, because the smallest element is at 2. Since see, array at 2 is the smallest among these elements, right? All these elements, these are the range we have given. So from here to here, this is the smallest element, right? So a smallest element is 12, and that's why we can jump there. So that is greater or equal to the array at 0. Now we cannot jump any more, right, because we are at here. From the starting index 1, let's suppose we are going to here, and again we can say here or from here. We can make our first jump to 3. Either we'll come to here, right, or either this jump can be come to here. Okay, so we cannot jump any more from here to any other places, right? Both jump can be come here. Next, what is saying, but we are not reaching to the last one. Okay, next we are coming to index I equal to 3, right? So we can make our first jump to I equal to 4. Okay, so from here we can make a one jump to here, and we have reached the end, so we can count one output. Okay, next from the starting index, that is at here, if we make any jump, so we are already at the end, right? So we do not require any more jumps, right? And that's why these two count is there, 1 and 1. This is the starting index 3 and 4, where we have to reach at the end. Okay, so in total there are two different indices, I3 and I4, as you can see here, and we can reach at the end of the number of jumps, and that's why we are getting output 2. Similarly, let's suppose we have given this one. Okay, so we are starting at index I equal to 0, 0, 1, 2, 3 and 4, right? So we can jump where a smallest element. Either I can jump to where I equal to 1, right, because this is the odd one, right? And we can jump to I equal to 2 or I equal to 3, either greater or either smaller, right? So during our first jump, that is the odd number, right? So first jump is odd number. We first jump to I equal to 1 because this is the odd number, and array at 1, right, is the smallest value in this range, right? This and this and this, okay, and that is greater than equal to AF0. It is greater than or equal to 0, right? So smallest number is now updated to which number? See, this is the largest among the 3, 1, 1, but according to the question, this is the smallest number, right? Because it is saying that it should be greater than or equal to this number. Now during our second jump, what will happen? We will get even number from where I equal to 1 to I equal to 2. So if we'll go to from here to here, right, because array at 2, this element, right, is the largest value in 2, 3 and 4, these 3 elements, right, and which is less than equal to array at 1, right, at this element. So it is also largest value, but 2 is the smallest index, right, and so we can jump to I equal to 2 and not to the I equal to 3. Okay, so next jump we will make odd number jump, and we can start from I equal to 2 and I equal to 3, right? So array at 3 is the smallest value, and array at 2 array at 3, smallest value is array at 3, right, as you can see here, and array at 4 is the greater than all this element, right? So we can make I equal to from I equal to 2 to I equal to 3, right? This is the smallest element. Now we can't jump I equal to 3 to here because this is the odd number. First of all, sorry, this is not the odd number, right? And I equal to 3 to I equal to 4, so starting index I is not good, 0, this one is not good, right? And in the similar manner, what we can do, if the starting index is I equal to 1, we can jump to 4, right? And so we can reach the end because this is small and this is a greater, right? So one jump will be there. Okay, when we are starting at index 2, right, we can jump to I equal to 3 because this is the smallest, right? So we can take, but we can't jump anymore, so we can leave that. Starting index I equal to 3 is 1, and we can jump to 4, that is another count, and we have reached already. Now at index 4, right, what we have? Starting index, and we are already at that, and so 3. So 3 jumps we will make, right? And we can say in the total jump we had 3 different distances we have. So don't we take a little load on yourself, and we can just assume that the possibility is right, and you will understand these questions. Coming back to this okay, let's understand the third output, example. So here we have given 1, 2, 3, 4, 5, but indices are 0, 1, 2, 3, 4. Okay, so we can start from index 1, that is this one. Okay, so from here we have to find the smallest one, right? We can go to here, right? So this is the first starting index. From 3 we'll find the smallest one, so we can reach to here, so we will get another one. From 4, this is the even, right? So we can reach to here, and this is the third, right? Means total we can reach from the starting index to the end is 3, right? So the output is coming 3. Okay, I think you got me. So let's understand the constant we have given. So constant we have given the length of the, you can say, array greater than or equal to 1 and 2 into 10 to the power 4, and array length is this one. Okay, so this function we have given, and we have to implement this one. Okay, so before going to the jump, let's understand the odd number jump and the even number jump, right? So how we are understanding? First of all, what we have to do, you have to understand first, third and fifth are the odd number, second, fourth and sixth are the even number. So we have to jump the index j in such a way we can have this logic, right? So array at I should be less than equal to j, means this element should be small than this one, okay, if this is odd number. So that is called a smallest element, right? In other case, in the even number, if add is the even number, it should be greater than or equal to j, means array at I is the largest possible value, not should be the smallest one, okay. Not what you have to do, if multiple indices such are coming, means we have to make the smallest one jump, smallest jump, multiple elements are coming, right? So we have to check the smallest one, right? There may be a case for some index that are not legal jump, so you can skip that. Now starting index, you know, if the starting from the index you can reach to the end of the your array, right? That is called array dot length minus 1 you will reach, that is called good number, okay. So we have to return number of good number that is starting from the indices, right? So let's suppose again we have this example, we have given 10, 13, 12, 14, 15, right? 0, 1, 2, 3, 4 we have given, starting index 0 we have, and for the first jump, so if we are at here, from here, right? So this element, we have all these elements, the smallest element is what, 12 we have, so we can reach there. So this is your first one, but we have not reached here, okay. Next time what we will do, from 13 we'll check 12, 14, this one. So which one is smallest? This one is the smallest, right? So still we are not reaching there, right? Now we'll from 14, this is a 1, 2, 3, 4 and 5th. Now we are at 4, right? We will check the max largest one, which is largest. 15 is the largest, so we have got 1 because we reach at the end. Now 15 is here the element, right? So 15 is already at the there, so we'll do one more jump. So total jump is 2, that is the good number we have, okay. I think you got me, okay. Now we have to find time complexity and space complexity after this understanding, right? So we'll you can note this is the time complexity we will find, n log n and O of n, right? So how we will implement this one? First of all, we have given array dot length, right? So how we'll calculate, n is, we can find our length and we will take one result, okay. So we'll take boolean and we'll mark as by default this all elements are false, and we'll take lower is boolean at n, it's a lower bound we'll take, and we'll say higher n minus 1 equal to lower n minus 1 we will mark as true. Every higher n minus 1 and lower n minus 1 both are true, right? We'll take a tree map and we'll store all these element here. How? We will put n minus 1 and n minus 1 like this, right? We'll start from the n minus 1 and then n minus 1, and we'll iterate over this element, right? Because we have to we have to reach at the last index, right? That's why. Now what we will do, for n minus 2 from the last 2 element we'll move to the 0 and do I minus minus, so that from the last element of the array, let's suppose this is your array, okay. So this element in length is n, so n minus 1 is the index and this is your 0 index. So from here we will go to here, and that's why we are making the loop like this, okay. So from this we have already stored this index on this element, right? At where? At the you can say map, okay. Here as you can see we have already stored. Now from here to here, right? From here to here what we will do, this is your n minus 2 index and there will be some element, okay. So this element from here to here will come and will store onto the map. How we'll do? We'll take a selling entry, right? Array at I will take, and there is that is we'll call high, and the floor value will take on the loop, right? We have all high and low, and what we'll do, we'll check if high not equal to null, we'll store at high, right? If high is not null, then we'll store lower value, right, of the high. And similarly, if low is not null, then we'll take a higher value of this one. Actually we are getting you can say higher value and lower values at the element, and we'll check the index, right? We'll pass the index and we'll check its we have reached or not, right? For that we'll store higher, at higher and lower we'll check the element high, at higher we'll take high dot get value, and lower at will get lower at this value. Well, but we'll check on the cross, we'll check at lower, at higher we'll check lower, and at lower we'll check at higher, right? Whatever will come we'll store at here. Okay, and then we'll do higher at I, we'll do I plus plus, and we'll do map dot put, and we'll do array dot I and comma I. Okay, and finally we'll return, we will have all the elements, high low elements we have, and we'll come to here, means its index value will be there and element will be there, and finally we'll return this result. So this result contains you can say we are adding this value, so each time if we get the higher value, right, this value will get incremented, right, and finally that element we are storing at these indexes, right? So this will give you your result, and for that the time complexity is O of n, and because we are using tmap auto sorting, and here we will take O of n as a time complexity, sorry, space complexity. Okay, thank you guys, thank you for watching this video. If you like this video, please hit subscribe this channel so you will get more videos like this. Thank you guys.